In this video, we'll talk about how to solve a system of three equations. So let's check out our example here. We have these three equations, and we're trying to figure out what are the values for x, y, and z that would make all three of these equations true. So the first step that we can do is we can try to convert these three equations into just two equations. And we can do that by eliminating one of our variables. So if we notice, this first equation has a plus 5y, and the second equation has a negative 5y. So if we were to combine these first two equations, we could eliminate that y very easily. So let's do that. If we combine these two, we'll have negative 6x plus 4x, that's negative 2x. We said the y's would cancel out. Over here we have 2z plus 5z, that's 7z. And then we have a negative 11 plus negative 4, that's negative 15. So here's one of our two equations. Now to get our second equation, we want to make sure that we use this third equation down here because we need to use all three of these equations when we're first reducing to two equations. So if you'll notice, we're trying to get rid of the y's. So if we consider these two equations right here, how could we multiply this third equation by some value to cancel out this y? Well, we'd have to multiply by 5 because that would give us a positive 5y, which could cancel out with that negative 5y. So let's multiply this whole equation by 5. So we get negative 2x times 5, that's negative 10x. 5 times y is plus 5y. 4z times 5 is 20z. And negative 9 times 5 is negative 45. So remember, we're going to use this new equation to eliminate the y in the second equation. So let's rewrite the second equation right here. 4x minus 5y plus 5z is equal to negative 4. And now if we combine these two equations, 4x minus 10x, that's negative 6x. These y's will cancel out. 5z plus 20z is plus 25z. And negative 4 plus negative 45 is negative 49. Okay, so here's our second equation. So we have now reduced these original three equations into just two equations. And now the last step is we want to reduce it to just one equation with one variable. So if we notice, if we multiply this first equation by a negative 3, we could get a positive 6x, which would cancel out with this 6x right here. So let's do that. So we'll get negative 2x times negative 3, that's positive 6x. Negative 3 times 7z is negative 21z. And negative 3 times negative 15 is 45. So now if we add these two equations together, the x's will cancel out just like we planned. And then we have 25z minus 21z, that's 4z. And then negative 49 plus 45 is negative 4. So now we can see that this equation only has one variable. So to solve for z, we can just divide both sides by 4. So if we divide by 4, we can find that z is equal to negative 1. Now that we know z, we can work backwards and say, let's plug in a negative 1 right here. So we would get 6x minus 21 times negative 1 is equal to 45. And we'll be able to solve for x. So we have 6x plus 21 is equal to 45. If we subtract a 21 from each side, we'll get 6x is equal to 24. And if we divide both sides by 6, we can see that x is equal to 4. So we now know z and we know x, so we can plug the z and the x values into any of these original equations and solve for y. So for example, let's plug into this first equation here. So we have negative 6 times x we found was 4, plus 5y, plus 2 times z we found is negative 1, is equal to negative 11. So we get negative 6 times 4 is negative 24, plus 5y. 2 times negative 1 is negative 2, is equal to negative 11. So now we have negative 24 and a negative 2, that's negative 26. And if we add 26 to the right-hand side, we'll get 15 is equal to 5y. And to solve for y, we can just divide both sides by 5, and we get y is equal to 3. So our final answer we can write like this, x, y, and z. So x is 4, y is 3, and z is -1. These are the x, y, and z values that if we plug them into any of these original equations, they will all be true.